All right, this is question 45, and it says to solve and write your solution in interval notation. So I know this can be a little bit tricky, but when you see 7 minus 2 here, I know you want to subtract that, but don't do it. Ooh, man, I banged my screen here. Don't do it. I got real intense. Because you see that this right here means you're going to be multiplying, which means you have to distribute before you can combine things like adding and subtracting stuff. So don't do this first. You have to distribute first. So we're going to start with, I'm just going to write down the 7 over here. And then I'm going to multiply negative 2 times x. So I get negative 2x. And then negative 2 times negative 4, which gives me a positive 8. And then I'm going to bring down my less than symbol. And then on the other side, we have 5 minus 10x. Okay, so we're looking for some like terms here. And I see that I have 7 and positive 8, which are like terms. So I'm going to go ahead and rearrange this to put 7 plus 8 and then minus 2x here. I'm going to rewrite all the rest of this the same way. And we're going to go ahead and combine our like terms. So 7 plus 8 is 15, and 15 minus 2x less than 5 minus 10x. Okay, so now we have a choice to make. We need to decide which side do we want our variables to be on and which side do we want our numbers to be on. And my personal preference is always to move the variables to the left-hand side when it comes to inequalities, because I like my variable to be on the left-hand side. So what I'm going to do is I'm going to be adding my 10x to both sides here. Okay, so bring down my 15 and then negative 2 plus 10. If you need to use a calculator, oops, I forgot my negative sign. Negative 2 plus 10 is going to be positive 8x. So plus 8x less than 5. And remember that this here is going to be 0. Okay, plus 0. Now we need to subtract the 15 to the other side, so minus 15 here. And then I'm just going to come up here and rewrite what we have here. So we have, this is now 0. And we have an 8x on the left minus, I'm sorry, not minus, less than. And then we have 5 minus 15, which is going to be equal to negative 10. Okay, so then the last step to get the x by itself is to divide both sides by 8. And we have x is less than. Now, you might be wondering, are we supposed to be flipping the inequality? And the only time we flip the inequality is if we multiply or divide by a negative number. In this case, I have divided by a positive number, and therefore I don't want to reverse the direction of my inequality. I do, however, want to simplify my fraction and reduce that. So if you need to, in the calculator, you can put negative 10 divided by 8 and then just hit math, enter, enter, and it will give you your reduced fraction, which is negative 5 over 4. And the instructions say to solve and then write in interval notation. I find it's easiest to graph it so that I know which way to write my interval notation. So I'm going to go ahead and put my negative 5/4 right here in the center. And then I'm going to decide which direction would I need to shade. Well, it says x is less than, right? Look at how that looks like a less than symbol. This is why I like my x to be on the left-hand side of my inequality, because then I can use this little trick, which is that this less than symbol right here happens to kind of look like this arrow this direction, right? Oh, look at that. And then we're shading all of this here. Now we have to decide if we're going to use brackets or parentheses. Since this is a strictly less than symbol, it doesn't have this, right? So if it doesn't have this line, then you're going to use parentheses. So we're going to go ahead and put a giant parentheses here. And then we need to know, what is this going towards? Well, this is negative infinity. Now, again, it is a little bit tricky because I know when you graph this, you instinctively think I'm starting at negative 5/4 and I'm going towards negative infinity. However, when you write your interval notation, it must match with a graph exactly. So where you see a negative infinity is on the left-hand side on the graph, it should be also in the interval. And then it's going to go up to negative 5 over 4. And then we put a parenthesis. That's why we do the parentheses instead of the circles on the graph, because it matches really nice with interval notation. So this is our solve and our interval. Okay, number 46, solve the inequality and write an interval notation. So similar, this time we have, I'm going to go ahead and just write the problem over here so that we have some space to work. But we have a greater than or equal to symbol this time, so it does have the line underneath. And we have a similar situation where we can choose to move our variables to the left or to the right. And again, I like to keep my variable always on the left, so I'm going to subtract 13x on both sides. This is not the only way you can do this problem. This is just the way I'm choosing to do this problem. So we are going to get now 7 minus 13. Again, if you need your calculator, then go ahead and do that. You get negative 6x plus 15 is greater than or equal to 51. So now we would subtract our 15 on both sides. So 51 minus 15 gives us 36. So we have negative 6x is greater than or equal to 36. Now it is very important that when you are working your way through the inequality, the same way you would be working your way through an equation, you don't want to change your inequality, right? Like I know a lot of people maybe in school learned that, oh, just change it to an equal sign and work it the same way you work an equation. Mentally, yes, you in your mind kind of change it to an equal sign, but never on the paper. And the reason why is because there are situations where you may have to flip your inequality. So I'm going to just kind of highlight that these have been left the same on all of these problems here. See how I'm just leaving it and I'm just carrying it all the way down the same way you would carry down any other inequality or equality, right? If it's an equal sign, you carry down an equal sign. Now, on this particular problem, I'm just going to come up here and rewrite it as negative 6x greater than or equal to 36. And you might notice that now I'm going to have to divide, but this time not by a positive number. This time I'm dividing by a negative number. So when I divide by negative 6 on both sides, what happens is I have to now flip my inequality. Now, if you're just carrying down an equal sign, this is where you run into a problem because you don't realize that you need to be flipping something. But because I'm dividing by a negative, I'm going to go ahead and flip my inequality all in the same step. This now becomes a positive x, and this is going to be a negative 6. So we have x is less than or equal to negative 6. That is my solve. But now I need to write it in interval notation. So again, I'm going to just draw a quick number line here. That way it'll help me. And it says x is less than or equal to negative 6. So this time when I go to the left here, I am still going less than, right? But this time I'm going to put a hard bracket like this because it does have the line underneath. And again, this is negative infinity here. So when we write our interval notation, we put parentheses always on negative infinity and positive infinity because the parentheses indicate that you don't include the value, and infinity is not a value. It is a concept saying that it goes on forever and ever. So you can never actually include infinity or negative infinity. Therefore, we will always put parentheses on those. All right. And it should match your number line exactly. Should be exactly the same. Okay. Number 47, find f of negative 3. So in this case, we are going to be replacing this is going to replace the x here, but it's also going to replace the x here and here. So we have f of negative 3 means everywhere you see an x, you're going to be replacing it with a negative 3. There we go. Let me go ahead and just highlight all of those places, the same as I did above. Okay, and now we just simplify the right-hand side. So using order of operations, we would do well, parentheses first, right? But inside the parentheses is just one single number. So we don't really have anything to simplify there. So the next step would be exponents. So I have 2 and then negative 3 squared. Now, here's something I really want to point out to you. If you type this in your calculator, which I imagine many people do, you have to put parentheses, then your negative 3, close your parentheses, and then square it. Okay, this is going to give you a positive 9 because negative 3 times negative 3 is positive 9. Now, let me show you something. If you don't put the parentheses and you just square it, you're going to get negative 9. And see, what the calculator thinks is you're saying that you want to take the opposite of whatever 3 squared is, right? Versus I'm wanting to square a negative 3. Okay, so there is a big difference in the way you type it in. So be extra, extra careful about that. Make sure you always put parentheses around a number before you square it, especially if it's negative, because that's where you will run into problems trusting the calculator. Remember that squaring means take whatever that number is times itself. So you could also type in just negative 3 times negative 3. Oop, wrong number. Oh, no. Oh, no. There we go. And you're going to get positive 9, right? So just keep those things in mind. Okay, now we have negative 4 times negative 3, which is going to become a plus 12 and a plus 5. 2 times 9 is 18. Okay, and then this is where we're at. Perhaps I should have... Oh, I don't know why I just said that. I meant to do this. Maybe I want to do all of this in one step. Oops, change that there too. Okay, so let me just write this down. So I'm going to show my steps. Okay, here we go. Now we have 2 times 9 is 18, negative 4 times negative 3, positive 12, and then plus 5. And then if you add all those together, 18 plus 12 plus 5, you should get 35. Okay, so your final answer here is f of negative 3 equals 35. That would be your final answer. Now, if you had to write that as an ordered pair, you can. The x coordinate, of course, is the thing that was in the parentheses right here. So as an ordered pair, this would be the answer. I don't know that you need that, but just in case, that's how you would do it. Okay, 48 and 49 say to factor out the greatest common factor. So greatest common factor is the largest thing that you can divide all of your terms by. So in this case, I start by looking at the numbers and I say, okay, I've got 2, 4, and 8. I'm ignoring the signs and I'm ignoring the variables, but looking specifically at 2, 4, and 8, I notice that all of those numbers can be divided by 2. And in fact, 2 is the biggest one because, well, I can only divide 2 by 2. I mean, I can't divide it by anything more than that. So my GCF for just the numbers is 2. But now if I look at the variables, okay, I see I have x to the third, x, but then this one doesn't have an x right here. So this is the entire greatest common factor, just 2. So what we're going to do is we're going to rewrite this as 2 times what gives me 2x cubed. Well, that would be x cubed, right? Plus 2 times what gives me 4x. That would be a 2x there. Plus 2 times what gives me negative 8. Well, that would be a negative 4 there. Now, in doing so, I see that my GCF 2, 2, and 2, right, is right there on all of those. And so now when we factor it out to the front, everything that's left over, see this 2 is here. Now, all the leftover things are going to go inside. We have x cubed plus 2x. And then I have plus negative 4. Now, you can just put minus 4 here. You don't have to put plus negative 4. But you should always check your answer by distributing back through. If I multiply that 2 times everything that is in the parentheses, I should come back to my original problem. And I would encourage you to always check that. Okay, but that would be your final answer there. Okay, 49. All right, looking again at just the numbers. I have 3, 9, and 27, and it looks like all of those can be divided by 3, so just the number part first. I know there's a 3. Now we're going to look at the variables. I have x to the 4th, x squared, and x. So they all have an x, which means x is going to be a part of my GCF. So I'm looking for the smallest exponent. In this case, this is the smallest exponent. It's a 1. So we're going to put that over here, 3x. Okay, and we can do the same thing that we did on this last problem here, where we put the 3x times what gives me 3x to the 4th. So you're kind of, in essence, dividing this out, right? Like 3 divided by 3 would be a 1. X to the 4th divided by x would be x to the 3rd power. Okay. Now, if you want to leave your minus sign in the middle, since our GCF happens to be positive, we can do that instead of putting a plus and then a negative. Up to you. On this other problem over here, I did a plus sign and then I put the negative here. I could have just put the minus sign right here, though, and then made that a 4. But the key is that you only put it in one of the places. So either the minus sign goes here or it goes here, but it can't go in both places. So you just have to decide how you would like to do that. So for this one, I'm just going to still put plus 3x times what? So now 3x times what gives me negative 9x squared? Well, I'd have to have a negative sign, and it would have to be a 3, because 3 times 3 is 9. And then I have x squared, oops. And so x times x would give me that x squared. Plus 3x times 3 times 9 gives me 27, and then x times 1 would give me x to the 1st power. So now my GCF, 3x, 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 okay? And so that's going to move to the outside of my parentheses. That's what I'm factoring out. My 3 looks kind of weird. Let's try that again. Okay, and then we're going to put a 1x to the 3rd, or just x to the 3rd. I have plus negative 3x. So I'm just going to put minus 3x here. And then I have plus 9 there. Okay. And again, you should always go back and double check to make sure that that does in fact distribute out to the correct answer. So my final answer, and it does, of course, because x times x cubed is x to the 4th, right? 3 times, I'm not obviously doing the 3, but anyways, make sure you double check that. Minus 3x plus 9. There we go. And close that up. Done. Okay. Number 50. 50 through 56 is factor completely. So we are first going to look at how many terms do we have. If we have, well, before we even look at the number of terms, do we have a greatest common factor? Actually, that's always step number 1. Is there a GCF? GCF. So when I look at all of my terms, I see x cubed, negative 5x squared, 4x, and negative 20. So I notice that the coefficient on the first term is a 1, which means for the number, GCF can only be a 1. And I noticed that my last term here doesn't have an x. There's no x, right? There's no x. So if that's the case, because these two have nothing in common, then it doesn't really matter what's going on in the middle, because there is no GCF for the entire problem. So the GCF is NA, not available, or doesn't exist. No, I don't want to say doesn't exist. Let me just say none. Or let me do this. GCF question mark. No. Okay, how about that? There we go. So we checked for GCF amongst all the terms. There is not one. So then the second step is, how many terms do we have? Number of terms. In this case, there are 4, right? They're separated by the pluses and minuses. There's 1, 2, 3, 4. That's my 4 terms. So if there's 4 terms, what should we do? Always grouping. Okay, so we're going to do factor by grouping. I'm going to group together the first two, x cubed minus 5x squared. Always put a plus in the middle, regardless of the sign. Okay, so no matter what this sign is right here, you still always put a plus here. Whatever this sign is just goes inside the parentheses with the 4x in this case, but always a plus sign here. Make sure you do put that so that you're showing it's not factored yet. All we've done is throw some parentheses in here. So now I'm going to look for my GCF of the first group. And in this case, that's going to be x to the 2nd power. So that's going to leave me with x minus 5. Then for my second group, put my plus sign there again, 4 and 20 can both be divided by a 4, so I'm going to factor that out, and that's going to leave me with x minus 5. Now, ultimately, what you want to have happen is that you want these things to match, right? Those need to be matching. And as long as they are, that means that you've done this correctly, okay? So now that those matched, we're going to factor that out, and that's going to leave us with x squared plus 4 here, and then your x minus 5 here. This would be your final answer. Now, if I could factor x squared plus 4 more, I would. However, x squared plus 4 is the sum of squares, and therefore this is prime. And so this cannot be factored further. Okay, number 51. Similar thing. Step 1, look for a GCF. Is there a GCF amongst all 4 terms? And for the same reason, no, I lied. I lied. I was about to say for the same reason, but when I look at all these numbers, 2, 4, 6, and 12, they're all even, which means there is a GCF, and it happens to be 2. GCF equals 2. So I'm going to go ahead and factor that out. Man, I really need to put some dividing lines here. Let me see if I can maybe move this over here just a smidge. Okay. Okay, here we go. Let's try this. All right, so now we're going to factor out a 2. That's going to leave me with x to the third minus 2x squared minus 3x plus 6. Okay, now after I've done my greatest common factor, I look at the number of terms, right? Number of terms. And there are, again, 4. So we will, again, do grouping. The key to this one is that you can't forget that 2 that's in the front there. So that just has to stay all the way through your problem. Okay, so I'm going to just keep the 2 here. And I'm going to put a square bracket. And we're going to group together x cubed minus 2x squared. Always put a plus in the middle. Put negative 3x plus 6. Okay, notice that I carried the sign over with 3x. Okay, so now in my first group, I can factor out x squared. That leaves me with x minus 2. And in my second group, because I want my parentheses to match, I need to factor that negative out. So I'm going to factor out the negative with the 3, and that's going to make this now a positive x. This is going to make this a minus 2. Okay, so now I've got this x minus 2 here and this x minus 2 here, which is perfect. Oh my gosh, I really did not leave enough space for this problem here. I'm going to write it a little bit smaller. Okay, so now I've got x squared minus 3, and then we have x minus 2. Okay, now I did mention on the last problem that because this was a sum of squares, it was prime and couldn't be factored further. Oh, never mind, I lied. This is a difference, however, it is not a difference of squares. This is not a perfect square. I mean, technically it could be, but no, it's not in what we've been normally. If this was a 9, x squared minus 9, then we could do an x plus 3x minus 3. However, this is not a difference of squares. It's a difference, just not perfect squares. This one is not. Therefore, this would be our final answer. So I'm going to need to, maybe I can write this a little bit bigger. Let's see here. Oh, no. No. Undo. What did I do? I was hoping, y'all, I'm just not very good at this iPad. I was hoping I could make this. Well, I was going to try and make it bigger. I guess I can't do that. Well, regardless, this is my final answer here. Okay. Let's go ahead and put that straight line there. Alrighty. Moving on. Okay, next one. So same thing. Always start with, do you have a GCF? And in this case, again, I see they're all even numbers. So there is a GCF because they can all be divided by 2. And they don't all have variables, right? This is t squared t, and then there's no t here. So therefore, it's only the number that is the GCF. So we're going to go ahead and do that. Let me just, sorry, divide my screen up here. There we go. Okay, so now I've got my GCF of 2. Gonna slide that over just a bit. All right, now let's factor it out. 2 factored out gives me t squared minus, what's 28 divided by 2? Is 14, right? 14t. 96 divided by 2, 48. I should use my calculator. 96 divided by 2. Yep, 48. 28 divided by 2. Yep, 14. Okay, good. I can math. All right. Next thing, we need to now see how many terms do we have left, right? So number of terms. There are 3 this time. And so you should look at a couple things. One, is there a number right in front of your t squared or x squared or whatever your squared term is that you haven't factored out, right? In this case, I've already factored out a 2. So now what I'm looking at is this one right here. Is this just t squared or is there like a number in front of it? Well, since it's just t squared, we can do undo FOIL. Okay, we don't have to go AC method. However, you can use AC method if you would like to. Okay, but I'm going to go undo FOIL. Okay. And that's specifically because there is not a number right here. Okay. So we're just going to set up our 2 parentheses. That would be the opposite of foiling. And we're going to put t here and t here because t times t gives me t squared. And I'm looking for 2 numbers that multiply to 48 but add up to negative 14. Okay, so if this last term happens to be positive, right? If that's a positive, that means your signs are going to be the same sign. So then you look at, okay, what's the middle sign, right? And if the middle sign is negative, right? Then that means these 2 are both going to be negative signs. Okay, because they have to be the same. So I'm going to put minus and minus there. So now I'm looking for 2 negative numbers that when you multiply them give you positive 48. When you add them give you negative 14. So if I start listing out numbers that multiply to 48, I would find here, I'm going to just, because I know I'm going to put my answer right here. Let me list out my factors of 48. And I want them to add to negative 14, right? So we know they're going to both be negative. So negative 1 and negative 48, negative 2 and negative 24, negative 3 and negative 16. Man, I'm quickly running out of space. Negative 4 and negative 12. Okay, hold on. I don't have the space, guys. Wish I had more. I should have left more space. This is my fault entirely because I'm the one that created this document and put all this non-space here. Okay, now there's another way you can do this in the calculator if you want me to show you. If I'm looking for factors of, let's see here. So I need factors of 48. I'm going to go to y equals, okay? And let me clear out what I've got in here. Oh, clear that out. Okay, why is that not doing that? What? Okay, here we go. Try again. Okay, if I'm going to go to y equals, I want factors of 48. If I put in 48 divided by x, the x button is right next to your green alpha button, okay? Then I go to the next column and I put in the same thing, 48 divided by x, but then I put plus x. Now when I go to look at my table, so second graph, oh, hold on. Let me change my table set. Yours should be fine, but now let's go to my table. Here we go. Okay, now in that red column over there, I'm looking for the number negative 14. Once you find it, oops, there it is. Okay, I've highlighted it. There's negative 14. If you look to the left, you're going to see negative 6 and negative 8. Those would be the numbers that you want to put here and here. Now, I've already put the negative signs, right? But -6 and -8. And that's literally all you have to do there. So this would be your final answer. 2 times t minus 6 times t minus 8. So if you struggle to find factors, you know, by hand, you can use a graphic calculator to help you find them. Now you can also, you know, go to your main menu and just divide, right? 48 divided by 1, enter. 48 divided by 2, enter. Oops. Oh my gosh, y'all. Oh my gosh. Enter. 48 divided by 3, enter. 48 divided by 4, enter. 48 divided by 5. Okay, now that one shouldn't work, right? Because 48 doesn't end in a 5 or a 0. But there you go, there's your decimal. 48 divided by 6, enter. Right? 48 divided by 7 doesn't work. And then when you get to 48 divided by 8, you get 6. And now your list repeats, right? You have 6 and 8, 8 and 6. So you know that there's no more, right? That's how you know you get to the end of your list. Okay? So you can do it that way too, and then throw your signs on at the very end. However you like, whatever works for you. Okay, looking at number 53. Once again, I will look for a greatest common factor. Always start with that. And in this case, there is not one. So second step, number of terms is what you're looking at. Number of terms. And I see that I have 3. And the number in front of x squared is a 1. Therefore, I'm going to do undo FOIL again. Same as what I just did, right? So you're looking for factors of, 48. Actually, negative 48 this time. Okay, so if you happen to see that, so we know it's going to be x and x here. If you happen to see that your last sign is negative, let me see here. What color should I use for I probably should have used blue for positive and red for negative. So red is negative. Okay, and then can I change this to blue, y'all? Let's go blue. Blue. Okay, blue for positives, red for negatives. Okay, there we go. So if your last sign is a negative, that means you have to have opposite signs in the middle. One positive, one negative, right? So it doesn't matter where you put them, you know, 1 plus and 1 minus. You can do the signs now or at the end. It doesn't matter. Honestly, I usually wait until the end. I do the numbers first and then I do the signs after. But I'm looking for numbers that multiply to give me a negative 48. So if I wanted to use the calculator again, when I go to my y equals, instead of it saying 48, you need to make sure you put the negative, which is in parentheses at the bottom, in front of that. Make sure you do it on both. Okay, negative 48. Now when I go to my table, I'm looking for a negative 8, right? So look in your red column here, look for negative 8, and there it is. So we have negative 12 and positive 4. So I'm going to make sure I put my positive 4 here, my negative 12 here. It, again, doesn't matter if you want to put, here, let me just rewrite this here. Okay. If I want to do x minus 12 and then x plus 4, that's fine. Or I can put x plus 4 and x minus 12. As long as the signs match appropriately with the number, then you're fine. Right? You can't just switch the sign on the 12 and the 4. Like you can't put x plus 12 and x minus 4. That would, in fact, be a different answer. However, you can switch the parentheses. So you could also put x plus 4 or n x minus 12 this way. Okay? So the order is fine. It doesn't matter. Okay, I'm going to erase that. Okay. Let me see what my time... No, it doesn't tell me how long I've been recording. So I guess I'll keep going. All right, let's look at 54. All right. So on this one, look for a GCF. And in this case, number 1, GCF. There is not one. 6, 7, and 3 have no common factors. They don't all have an X, so we move on. Step 2, number of terms. We have 3, But this time we have a number in front of x squared. So we're going to do the AC method. All right, so I'm going to start by multiplying a times c, which in this case would be 6 times -3. So I get -18. And I'm looking for two numbers that multiply to give me -18, but at the same time add up to +7. So this is where the calculator can help you again. If you go to your y equals, you can come up here, and you can do this all by hand, of course, but -18 divided by x, then you can go here, -18 divided by x plus x. And then go to your table. You're looking for +7. So I see -7. I'm going to just keep going. There's +7. Okay, so -2 and +9. -2, +9, -2, +9. Okay, so what we have is this relationship. -2x plus 9x is equal to 7x. Why did I highlight that? Now, I haven't literally highlighted it, but I'm about to literally highlight it because I want to point out that this relationship here can be used to switch out the 7x. So I'm going to write 6x squared, and in place of 7x, I'm going to put -2x plus 9x minus 3. Now, why do we do this? What is the purpose of switching that out? Well, the reason we do it is so that we have now 4 terms. And then we can do factor by grouping, which is, of course, what we enjoy doing more. So now we're going to group together 6x squared minus 2x plus 9x minus 3. Now, does it matter the order? Like, does it have to be -2x plus 9x, or can I do 9x minus 2x? The order doesn't matter. It will still come out the same in the end, as long as you do all your steps right. Okay, so 6x squared and -2x. I can factor out a 2 and an x, which is going to leave me with a +3x and a -1. Remember, you have to have a placeholder there, because if I distribute back through, 2x times 3x is 6x squared. 2x times -1 gives me -2x. Okay, and then in my second group, I can factor out a +3. So I'm going to get a 3x and a -1 here. So now I've got my matching parentheses like I wanted, right? 3x minus 1. So now we have 2x plus 3 and 3x minus 1 has been factored out, and that would be our final answer. Of course, you can FOIL it and double check your answer. Okay. That's how much room I should have left for all the factoring problems, huh? Okay, number 55. Do we have a greatest common factor? The answer is no. 9, 30, and 25 don't have any common factors, so GCF, no. Second step, how many terms? Okay, let me set my box up here. Number of terms, we have 3. So this one happens to be a special case. However, sometimes you don't notice that. But in this case, looking at that first term, I would say, oh, this right here tells me I should do AC method. Absolutely, you can totally do AC method. But I also kind of notice, hey, this is 9 is a perfect square. And then I look at the last term and I said, oh, you know what? 25 is a perfect square also. So this one might be a special case where I have a perfect square trinomial. So if that's the case, if you notice perfect square, then you might want to try looking to see if it's a perfect square trinomial. Now, you can still use the AC method like we did up here, and you get the same end results, okay? So I'm just showing you an alternative way only for special cases. This happens to be special. What I'm about to do on this one cannot be used on this one up here, okay? What I did on this one here can be used down here. So just be aware of that. This strategy for this problem right here will not work for every trinomial, whereas AC method can work for every single trinomial. Even the ones that have a 1 in front of the x squared, you can still use the AC method. Okay, this one, so I'm looking at, I see this number here, but I happen to notice perfect square, perfect square. So I'm going to check to see if it's a perfect square trinomial. And I'm just going to say perfect square trinomial. Okay, so let's look. Can we write this as something squared? The answer is yes, 3x. Can I write this as something squared? The answer is yes, it's 5. Now, is 2 times 3x times 5, does that equal 30x in the middle? So let's check. 2 times 3 is 15 times 5, right? Did I check that right? 2 times 3 times 5. That does, in fact, equal 30, right? So this is 30x. Check. So what does that mean? That means that this is a perfect square trinomial. So my factors are 3x plus 5 squared. My gosh, this pen has a lot of drag. Keeps messing up my numbers. I guess I'm not picking up my... I'm writing too fast, maybe. Okay, so let me highlight where we went with things. This one goes here and here. Okay. This one goes here and here. All right, the sign in the middle here goes here. Okay, so if that had been a minus sign, we would have put a minus sign in the middle. But these, you do have to check that the middle term is 2 times the quote A and the B, which is the 3x and the 5. That has to equal your middle term. And as long as it does, so the middle term is this one right here, 30x. That has to go here. And you have to check that, okay? So as long as that works, you're golden. And then this is a special perfect square trinomial, okay? All right, last one. I think this is just perfect square trinomial. Okay. Sorry, guys. I know this is taking forever. Okay, next one. So GCF, number 1. Do we have a GCF? Yes. Oh, gosh, dang it. Erg. Just start this again. Okay. GCF. Yes, it is 5. Okay. So factor out the 5. That leaves me with x squared minus, what is 180 divided by 5? 36. Now, I see that next step is number of terms, right? I have 2. And if I have 2, I'm going to check for a difference of squares. And in this case, I do have a difference of squares, right? Because I can write this as something squared minus something squared, right? If I can do that, this is x and this is 6. So we have here x squared, and then we have 6 squared, right? So I can write this as 5. Don't forget the 5 has to stay in the front. This is going to be x plus 6 and x minus 6. So that 6 goes here and here. The x goes here and here. And then you have to put 1 plus and 1 minus. That is how you factor a difference of squares. All right. Seems like I should finish this page up and then stop the video. Okay. Number 57. For the following graph, f of x, determine these things. Okay, so when it says f of negative 1, remember that when it says f of negative 1, that this number right here is the x coordinate of an ordered pair, right? So that is the x. We want to know what is the y coordinate, right? So equals. So if you're looking at your graph over here, you're looking at where is there a point on this graph where x is equal to -1? So I come over to x equals -1, put a point right there, and I see that my y coordinate is a 1. I don't like that. Let me do that in black. It's a 1. So that means f of -1 is in fact 1. That's it. That's all you have to do. State the domain. Oops. So domain is going to be on your x-axis, right? So if you're following this graph down, squeeze it down to your x-axis. Everything this way, right? But at -4, we would go ahead and include this. So we would put a bracket. Oop, that didn't work. Let's try the pen. We would have to put a square bracket here at -4 because it does include, since there's a solid point there. So our domain would be a bracket at -4. And then since the graph does have this arrow on the right-hand side, it goes on forever. That's going to be positive infinity, and always parentheses on that. Okay, let me box this. Let me box this. Okay, and then for the range, okay, oops. Oh my gosh. Okay, so for the range, this is going to be bottom to top. So lowest point to highest point. Domain is going to be left to right. Okay, this is always left to right. This is going to be bottom to top. Okay, so the lowest y value to the highest y value. And so looking at your graph here, my lowest y value is right here at 1. So I'm going to put a little bracket like this. And then my highest y value is going to go on forever because of that arrow, right? So we would state that our range starts with a bracket at 1. And then the highest value would be positive infinity, because this is positive infinity up here, positive infinity here. Okay, that would be my range, bottom to top. So lowest to highest. All right. Did anybody else want me to fix this, or was that just me? Because I needed it to look better. There we go. Much better, y'all. Okay, I guess I'll stop this one here.